So the problem asks us to do partial fraction decomposition in order to integrate this problem. So to do partial fraction decomposition, we have to start by denoting A, B, and possibly C. So we're going to have, this is what's going to decide what our A, B, and possibly C are. Because we have this, we're going to have just a regular A. This is a bit trickier. This doesn't break down any, and so what we're going to have to do is we're going to have to make this bx plus c. So this is also going to have to be a function because this is a function that doesn't decompose anymore. So on the bottom of this, we're going to have x because our a relates to our x. And on here, we're going to have x squared plus 6. All right, so to solve this, we can start by cross-multiplying both directions, and that gives us ax squared plus 6a plus bx squared plus cx, and that's all going to be equal to the top, which is 5x squared minus 4x plus 12. All right, to solve from there, we can start by combining like terms. So we know that ax squared plus bx squared is going to be equal to 5x squared. We can just cancel out these x squares, and now we know that a plus b equals 5. Well, we can't automatically solve that, so we're going to have to go and look at our other things. So we know that 6a is going to have to be equal to whatever on this side that doesn't have an x in it. So we know 6a is going to be equal to 12. And then last but not least, we know that c of x is going to be equal to negative 4x. We can cancel that out. So automatically we know that a is equal to, well, we divide by 6. We know a is equal to 2. We know from this that c is equal to negative 4. And now we can solve for what b is. So we know that 2 plus b gives us 5. So obviously b is going to have to be equal to 3. And now when we go back and plug this into our initial equation, we have a, so 2 divided by x, plus b is 3, so we have 3x, c is 4, negative 4, my bad, x squared plus 6. And this is now the partial fraction decomposition of our original function.